In this video, we'll learn to calculate the percent composition by mass, and then we'll do several practice problems. Let's start with an example, CO2, carbon dioxide. We'll use this formula here to guide our work. So first we'll find the percent of carbon by mass in CO2. For the numerator, we're going to put the molar mass of the element. The element we're interested in is carbon here. When we go to the periodic table, we can see that carbon is 12.01 grams per mole. So we're going to write that in the top part of the equation. Then for the number of the element, we only have one carbon. When we don't have a subscript here, we assume that there's only a 1. So we'll multiply this by 1, and then we need to divide by the mass of the entire compound, the molar mass for CO2. To find the molar mass for CO2, we have our 1 carbon and then 2 oxygen atoms. When we add the molar mass for each of these elements up, we'll get a total of 44.01 grams per mole for the molar mass of CO2. You can think of it this way. We're looking for carbon, that's the part, and we're going to divide the part by the whole thing. We multiply this by 100, and that gives us our percent, which is 27.29. So this 27.29%, that represents how much the mass of the carbon is of the entire CO2 molecule. You can think of it like a pie chart. This blue piece here is the mass of the carbon in the entire carbon dioxide molecule. That tells us that most of the mass in the CO2 molecule is this oxygen here. So let's actually calculate the percent composition for the oxygen in CO2. So for the oxygen, we have a molar mass for one oxygen of 16.00 grams per mole. And the number of the oxygen atoms, we have 2. So we multiply this by 2, divide by the molar mass of the compound, which we found to be 44.01, and multiply by 100. That gives us 72.71%. These two percentages should add up to 100% or very close. You may have a bit of a rounding error depending on the periodic table you use. So let's do some practice. Pause and find the percent composition for each element in KNO3, potassium nitrate. So let's find the percent composition of potassium first. We have K. We take the molar mass of the element on the periodic table. K is 39.10 grams per mole, and we won't write grams per mole since we know it cancels out. We multiply by the subscript here on the K, which there's nothing written, so it's just 1. And we divide that by the molar mass of the entire KNO3 compound. That turns out to be 101.11 grams per mole. Multiply it by 100, and we get 38.67%. Next, we'll do the nitrogen, and it's the same process. And we divide the molar mass for nitrogen as found on the periodic table by the molar mass for the entire compound. We'll get 13.86%. Finally, for the oxygen, we have a molar mass for oxygen is 16.00, and we have 3. The subscript here tells us we have 3 oxygens. We multiply it by 3, and then it's the same process. And our percent will be 47.47%. So these numbers represent the percent composition for each element in KNO3. Let's try another one. Pause and figure out the percent composition by mass of just the hydrogen here in the CaOH2 compound. So we'll need to know the mass of the hydrogen, how many hydrogen atoms there are, and then the molar mass for the entire compound. Let's figure the molar mass out for the compound first. Calcium is 40.08 grams per mole plus, and let's just put our parentheses here, oxygen is 16.00, and hydrogen is 1.01 grams per mole. And we have 2, and this 2 applies to everything in parentheses, so I'll put it on the outside. When I do this, I'll get 40.08 plus 17.01 times the 2, and then my final molar mass will be 74.09 grams per mole. To figure out the percent composition by mass for the hydrogen in this calcium hydroxide, we have hydrogen with a molar mass of 1.01 grams per mole. And this 2, it applies to everything. We have the 2 oxygens, but we have 2 hydrogens. So we multiply this by the subscript there, 2, and we divide the whole thing by the molar mass of calcium hydroxide. We multiply that by 100, and we find the percent composition for the hydrogen in the calcium hydroxide to be 2.73%. You'd calculate the oxygen in the same manner, and then you could calculate the calcium. So pause and give these 3 problems a try. This last one here is a bonus question and might be a little bit challenging. So these are the answers, and if you didn't get these exact answers, go back and check your work, and then in the description there are fuller explanations for each one of these compounds. Note that the last one, copper sulfate pentahydrate, is a bit challenging, but it's one that we see quite often in chemistry. You might ask why we even want to calculate the percent mass. The reason is this is something we can determine in the lab, and then we can use it to find the empirical and the molecular formula for the compound. So it's quite useful for figuring out what the ratios are of the different elements in compounds. This is Dr. B with the percent composition by mass, and thanks for watching.